quick word about me. I'm Hasu. I lead strategy at Flashbots. I'm also a strategic advisor to Lido. I've been thinking and writing about the blockspace market and about MEV for over 3 years now. So in this time I've seen a lot of things. In this talk I want to share my insight why you can't get around if you're developing a blockchain, whether it's layer 1 solution, that's a sidechain, or it's layer 2. You want to build a block-based market that allows for efficient MEV extraction. So, to see why, let's look at what a blockchain actually is from first principle. Every blockchain has 3 components. First, a virtual machine that is replicated on thousands, if not millions, of computers at the same time. A consensus mechanism that keeps them all synchronized with each other. And the consensus actually breaks down into 2 parts. First is sequencing, which is selecting the next transaction to go into the block. In other words, propose a new fork of the chain that has one new block at the tip. And then attestation that is attesting to the fork, containing that new block at the tip, giving it economic weight in the fork just rule. And that weight in present-day Ethereum is a proof of work. After the merge, it will be a proof of stake. But in layer 2 context, for example, it can also be the absence of a fraud proof, together with data availability, or the presence of a zero-knowledge proof, or validity proof. Right? So, and the third component that we need is a block-based market. And that is the topic of today's talk. So why do you need a block-based market? The question that almost everyone asks in the beginning, and they hear about crypto, is why can't we have infinite block space? Why can't we just make blocks as large as we want, and that will create a large amount of supply for users? So that's why I gave the definition of what a blockchain is. So every transaction that you do must be replayed and stored by all nodes forever. I put an asterisk here because it's not like strictly true, but in either case, all the nodes have to store what the current state is, and that can also get very large very quick. To maximize the number of participants in a decentralized system, we want to minimize the amount of resources that each of them has to consume in order to stay in sync with the network and also catch up to it when they sync from scratch or from a last checkpoint. And that means you have to limit resource consumption to a point where people with consumer-grade hardware that can also participate. So that's the reason why Ethereum, for example, has a gas limit, among other reasons. So if you are starting from the assumption that you need finite block space, then the question is, how do you allocate this block space efficiently? And different blockchains have tried different market mechanisms for that. First come, first serve, or various forms of batch auctions, as we will see. So to look back around to the first slide, a transaction starts in the block space market, then is picked up by a sequencer, then is tested to in a block, eventually makes it into the next update of the VM state. Designing block space markets used to be really easy. So 3 years ago, there were very few people thinking about block space market design. Why? Because it was not an interesting problem. The problem that people were thinking about at the time was gas price estimation. So that was the only problem that people were dealing with in real time. So how much should you bid to get your transaction included in the time that you want? And because gas price estimation was really poor, it led to a lot of online overbidding. Transactions got stuck, or people were overpaying, or the prices were swinging really hard. And so, some time ago, we implemented ERP 1559, turning the market from fixed supply. So there used to be like a fixed limit on the amount of gas that can be in a block, and then the price would float, so as supply and demand met. And ERP 1559 replaced that with a floating supply, and the market quoting you a fixed price. Right? And that this leads to the same amount of gas being consumed, but it has way better UX. This update has been so good that it has since been picked up by virtually every smart contract blockchain that exists. So this has been a large success. You can consider the original problem of gas estimation solved. MEV enters the room, and as you can see, the amount of MEV that is being extracted from public blockchains is going up in some. And what this means, basically, MEV has made blockspace market design hard again. Why is that? MEV transactions have complex preferences for placement. Okay, so an MEV transaction wants to be positioned at a very specific point in a block, also in relation to other target transactions. For example, if the MEV transaction is doing inter-block arbitrage, so arbitrage between two blocks are being mined, then it wants to be first in the block or very early. If the arbitrage is done within a block, then it wants to be positioned right after a target transaction. For example, like a trade that unbalances a DEX pool, for example. If it's a liquidation, then this is a similar format. So you want to be positioned right after the Oracle update, so you can be the first to arbitrage away the opportunity. And with the sandwich, it gets even more complicated because you want to be right before and after a target transaction. And it doesn't even have to be just one. A sandwich can have in the middle an arbitrarily large number of trades, as long as they're all going in the same direction. So you might even want to say, I want to put 3 trades here in the order and then put mine in front and in the back. So these are typical sandwiches that you're seeing. So what this means is, if you have an unexpressive market, i.e. a market where that doesn't allow the bidders to express their complex preferences, and you have bidders with complex preferences, and these bidders have a large incentive to get their transaction at exactly the point where they want, then the result is a lot of negative externalities for your blockchain. So, if your market mechanism, and these include all of the ones that we will go through in a second, informs what MEV extraction strategy searchers, trading firms, etc. will use. And depending how expressive your market is, and if it's optimized for MEV extraction, we will see various forms of negative externalities. So in the following slide, we will now go through different market mechanisms and the MEV strategy that it leads to and the negative externalities. So the first one that everyone should be familiar with is the transparent batch auction. That is what Ethereum is largely still using today and has been using for the last years. So what this means is transactions accumulate in a public mempool, and then on average 12 seconds, a mining pool, like a builder, takes these transactions, bundles them into a block, and then the miners test it and it gets updated. So, and how do you compete in the strategy? So for one, you want to be the first to see new transactions that enter the public mempool, so you can be the first to issue a response. Right? And then you want to be, so you have these two things, right? So you want to have a good view of the mempool, and then you want to have latency. And what this leads to is it leads to a lot of failed transactions. It leads to no front-running protection for users. And it leads to block producer centralization, because extracting this MEV is very hard, basically. And so you have an incentive for mining pools and miners to vertically integrate with trading firms. And there's actually an interesting anecdote here. So until I think 1.5 years ago, the dominant client that the miners use was actually different in the sense that when it saw 2 transactions that arrived at the same gas price, then it would decide randomly which one it would include. And so this had a different dominant MEV strategy, as searchers were like spamming spamming the miners and the network with many transactions in order to ensure that they would win the lottery. So then get changed how their client sequences transactions, and now the first transaction that is used, certain gas price, is the one that gets included, and the others get discarded. And so this is how it changed from spam being the dominant MEV strategy to latency. The sealed bit auction is the one that we have in Ethereum today via Flashbots and other MEV auction systems. So this has changed the game in a dramatic way, because now searchers have a lot more, can a lot better express what their transactions are supposed to do, where they are supposed to be in relation to target transactions. Right? And this has shifted this game from being a latency war and war on mempool view and on spamming the chain to one where the searchers compete on who can pay miners the most. And this is largely a function of how low can you get your gas, how high can you get your gas efficiency, how little block space can you use. So this has very few of the original negative externalities. It has one new negative externality, which is that now the block builder that is Flashbots has a lot more, like there's a new party that has a fair amount of power that didn't exist before, and that is only going to go up, as we have already seen in some talks and as we will see in more talks, as, for example, cross-domain MEV enters the picture. So the builder role, it will only go up in importance. That's really important. And then we will quickly go through some more. So we have transparent batch auctions with low fees and low latency, and this sort of has the same problems as the original mechanism, but it gets even worse as when the latency of the chain is really low. So when the fees are really low, you encourage spam, and when the latency has to be really low, then you encourage basically vertical integration between mining pools and searchers. So that's not the scenario that you want, right? So in this system, for example, you would not be able to have a system like Flashbots, because Flashbots, even if it's an open system, would lose to one that is co-located with different mining pools. So you would have to re-architect what a system like Flashbots is from the ground up. So in the previous talk by Xinjuan, we have seen why fair sequencing / fair ordering is extremely hard to do in a decentralized way. And if you try it in all of these other ways, then sort of it leads to many of the same problems, right? Because if you have fair ordering based on first come first team, then you encourage again a latency war that in the end game becomes co-location game. And so you really do encourage all of the nodes in the ordering system to co-locate with each other, so they can more effectively option off the co-location rights, if anything. So in either case, the system trends towards centralization as well. And then finally, you have the randomized batch auction. So this is something that some blockchains are experimenting with. For example, when Polygon does this, so Polygon, if you're a Polygon validator, you run actually two nodes. One that they call a sentry node that just accepts like all of the transactions, and then it forwards a random selection of them. So it's basically like, as a validator, you only see a randomized batch of options, but they're transactions, but there are like various ways you can do this. Like Neo, for example, has been thinking about doing a batch auction where the batch is randomized after going on chain. So you can have different ones. But the problem here is always the same. So the searchers are incentivized to spam, and the miners the validators who do want to extract the MEV, if they can't put the transactions in the place where they want, then they are incentivized to approach the problem from the other side, which is excluding all the transactions that they don't want, right? So you really end up going to a system where the searchers, or the validators or builders just emit all of the transactions that could mess up the ordering that they want to achieve. So you need a system where the parties are aligned in extracting the most MEV that is possible. You will not be able to do another way that doesn't lead to a lot of negative externalities. And as a very smart man has said, show me the incentive and I will show you the outcome. This is not something that I made up. These problems exist everywhere. Here's an example of airline extracted the value. German giant Lufthansa said it would have to fly an additional 18,000 unnecessary flights through COVID winter to hold on to their landing slots. Yeah, if you design a system in a way that parties have to do particular things in order to get a large incentive, then they will do it. So what are our takeaways? MEV exists, yeah. And the way that you set up your block space market, it shapes the dominant extraction strategy for searchers. And these extraction strategies create different negative externalities that hurt your users and the sustainability and robustness of your blockchain. So, dear blockchain architect, your choices have long-run consequences. Build mechanisms that acknowledge MEV, that acknowledge reality how it is today, and doesn't assume that MEV doesn't exist. Second, every blockchain needs fees to prevent spam and allocate scarce resources in the block space market. So every blockchain needs a block space market. Every blockchain needs a way to express complex preferences to accommodate for MEV extraction in order not to completely wreck your user experience. And competition on price is the least harmful and most efficient form of MEV extraction that we know so far. That might change, but today I would say it's definitely true. And finally, last slide, we have two bonus benefits. So if you run a market mechanism that maximizes competing for price, then you will also maximize the revenue of your block producer or block producers or a sequencer if you're layer 2. So even if you have a single sequencer layer 2 and you think you could really efficiently run a first come, first serve kind of system, you should still consider the trade-offs between using that and using an MEV option where the searchers compete on price. Because in the first come, first serve system, most of the value will be extracted by searchers, whereas here, most of the value will be extracted by the block producer and can be reinvested into your ecosystem, either by paying MEV back to users, or by using incentives to grow your blockchain, or by reinvesting into public goods funding. So, and final point, by making the searcher market more efficient, you will also improve the liquidity and plumbing of your DeFi ecosystem. So, your DeFi applications will be grateful if they can rely on a robust searcher ecosystem, where they can rely that the transactions in decentralized lending markets will be liquidated on time at the best price possible, and the same goes for arbitrage in decentralized exchanges, and so on. Thank you. I'm now taking questions. Due to the setup, you might probably have to, somebody ask the question, then probably repeat them to me.
Hi. So I saw the where you said if you have a system with very fast transactions and very low cost to the transactions, something like a Flashbots actually couldn't compete, and you have issues with spam and such. How does that interact with our drive towards having fast transactions and low fees in layer 2s, ZK rollups, and the like?
Great question. Yeah, I think it will require us to re-architect what a system like Flashbots would look like on another chain. I think the end game is for all blockchains to have an efficient like an efficient MEV market. But it's an ongoing topic of research for us and for other participants in the ecosystem, how that system can be created in a very low latency system. I think it's actually quite possible that this system will also involve some degree of co-location, because if you're not co-located with the block builder or the mining pool or the staking pool, then I think it will be impossible to compete with a decentralized system, with an open system, against the sort of private, vertically integrated systems that we are trying to prevent. I can point you to, so there are some systems that are trying to build this right now. I know there's Jito on Solana. I'm not 100% familiar how they work, but so there are already some versions of, like variants of Flashbots being built on other chains that have much lower latency, and so they could be a good indicator. Maybe they are even here at this conference and would be down to chat.
Thank you.
Hi, Hasu. I have a question on if you were to create a new sort of blockchain, is there a difference when with regards to MEV, whether the validators are known, let's say with Tendermint there's only 21, versus where it's completely permissionless and no one necessarily knows who the validators are?
No, I don't think it makes a difference. I think it's, if you don't have a system like Flashbots, then I think it's probably like the fewer parties you have, the easier, the more likely it is that the system will collapse back to some even greater state of centralization. Because, for example, if you're a searcher, then you know exactly who to approach and who to strike deals with and so on. But I think outside of that, no, I don't think there's a large difference.
All right, thank you, Hasu. We have to move on to the next speaker. Thank you for your presentation.
Yeah. Should I announce? Yeah.
Oh. Okay, thank you very much.